All right, so today we're going to learn how to factor trinomials when the leading coefficient is not 1. So these are going to be in the format of ax squared plus bx plus c. So you notice in the last video we didn't have anything in front of that x squared term. That was just a 1, but now we're going to have to take into consideration something that's in front of that x squared. But first, your joke of the day. What is a bird's favorite type of math? Algebra. That's a good one. Okay, so I'm going to teach you 2 methods on here. So I would suggest you watch this video and do not pay attention to any videos that are in my math lab. Because they're not going to show you this method, but these really are the easiest methods that I have learned that everyone can seem to understand. So our first method, so just remember this format, ax squared plus bx plus c. So if you've got something like 3x squared minus 7x plus 10, 3 is your a term, negative 7 is your b term, and your c term is 10. So whatever's in front of each one of those variables, a, b, and c. So here is the method for your big X method. Literally, we make a big X on the table, on your paper, I guess. So up here at the top, you're going to put whatever is a times c. So in that case, 3 times 10. Notice a times c, 3 times 10. Then down in the bottom, you're going to put your b term. So that's where that negative 7 would go. Then you're going to divide by the a term over here. So then you're going to come up with these factors that multiply to be a times c, but add to be whatever that b term is. Okay, and then you'll divide by a, we're going to reduce, and then those are your factors. Okay, so slide and divide says we're going to take this one, and I do not care for this method as much, but I'm going to show it to you, and I'll probably work a couple of problems like this, but for the most part I'm going to use the big X. Okay, you're going to slide this a term down here, leaving you with x squared plus bx plus that c times that a term. Okay. So then you're going to factor just like we did before. You're going to come up with factors of whatever that a times c is, whatever this term is down here, whose sum is that b term. And then you're going to come up with whatever these are. Okay, and we'll just say we came up with m and n. We don't know. But then you've got to remember to come back and divide by the a term. And it's not that much different, but for me, what I've seen over the years is that everyone forgets to come back and divide by that a term. So you're sliding a, but you've got to remember to divide by a if you choose this method, and then rewrite your factors, okay? And you reduce those and then rewrite them. Okay? But let me just show you an example. So here's method 1. I'm going to use the big X. Okay? So in this example, we've got 5x squared minus 14x plus 8. Well, in this case, a is 5, b is negative 14, and c is 8. So remember, up at the top, it's a times c. So 5 times 8 is 40. On the bottom is your b term, which is negative 14. Then we're going to come over here and divide by a. So you see, because I've already said that we're going to divide by the a term over here, then I just don't forget to do it. All right, so now we're coming up with factors of 40, whose sum is negative 14. So multiply to be this, add to be this. Okay, so what's that going to be? Well, how are we going to get factors of a positive number? But it's the sum would be negative. Well, it's going to be negative times a negative. So that would be 1 times negative 40. No, I think that's going to be negative 4 times negative 10, and that adds up to be our negative 14. So those are the two that we're going to use. So we're going to say negative 4 and negative 10. Now remember I told you that you're going to have to reduce here. Well, this does not reduce. Negative 4/5. So this 5, the number that's on the bottom, moves to the front of my binomial, creating 5x minus 4. Do you see how that creates? 5 moves to the front of the binomial, minus 4. Then this one, negative 10 over 5, will reduce to a negative 2. So that binomial is just x minus 2. Notice he's over 1, right? So that means the 1's moving to the front, and that's, just leaves us with just the x. So that is this thing factored. So it's sort of nice and easy to use this method. But I'm going to go ahead and show you method 2 here, which is our slide and divide. All right, so we are given, let's see, 5x squared minus 14x plus 8. So we're going to slide our 5 down to the other side, giving us x squared minus 14x plus the 8 times the 5, which is 40. So just multiply that, moving that 5 down. So now we're just coming up with, what are my factors of 40 that add up to be negative 4? Well, the factors are still the same, x minus 4, x minus 10. All right, but now we've got to remember to come back and divide by that 5, right? So we slid the 5 down, we've got to come back and divide by the 5. Well, this won't reduce, so he goes to the front, creating the binomial 5x minus 4. This one does reduce. 10 over 5 reduces to that 2, so that creates the binomial x minus 2. So there's your same answer, just different way to get it, okay? All right, so let's do a couple more. Big X, okay? A is 6, B is 19, C is negative 7. So top binomial, 6 times negative 7 is negative 42. The B term goes down here, so that's 19. We're dividing both sides by 6. So what times what is 42 that adds up to be 19? Well, we need factors of negative 42 whose sum is 19. I'm thinking negative 2 and 21. And that adds up to be 19. So those would be my two factors. So negative 2 and 21. If you need to spend a little bit more time coming up with those factors of 42, you go ahead and do that. All right, so negative 2 over 6, that reduces to negative 1/3. Well, remember, if something's on the bottom, that's going to create, he moves to the front and creates that binomial 3x minus 1. So we've got 3x minus 1. This 21 over 6, can that reduce? Three goes into each one of those. So if we divide each one by 3, that gives us 7 over 2. So 2 is going to move to the front, creating 2x plus 7, because that was our positive side. So that is that factored. Okay, I'll do the slide and divide real quick. So we're sliding down. So our factors here are x minus 2, x plus 21. Then we've got to remember to divide by the 6. So that makes 3x minus 1 and 2x plus 7 when we reduce that. Okay, you see how you get the same answer. Okay, let's do a couple more. How many did I put on here? 3 more. Okay, so hopefully we can get these done pretty quick. Okay, so again, remember, if that y squared's at the end, just remember that when you create these two binomials, you're going to have a y also at the end. Okay, big X. 3 times 4 is 12. Adds up to be the b term, negative 13. Dividing both sides by 3. Let's see, that looks like it'll be negative 1. It's negative 12. So this one cannot be reduced, so 3 moves to the front. This one is reduced to a negative 4, so that's x minus 4. And we're just going to remember that we put those y's there. So 3x minus the 1y and x minus 4y. Final answer. So if I do slide and divide, so you see we're getting the same answers. Sort of the same process. So hopefully you can sort of start working those on your own on slide and divide if that's your method of choice. Okay, so look at this. What have we got going on here? All of a sudden we've got this y to the 4th. Well, anytime I have something that's not squared, I'm thinking, and I hope you are too, GCF. Well, we've got a GCF of that y squared, so let's take that out first. And that leaves us with 5y squared plus 13y plus 6. All right, so now remember we're just factoring this, but when we write that final answer, we do have to have that y squared on the outside. So 5 times 6 is 30, adds up to be 13, dividing by 5. Well, that should be 3 and 10. So this one doesn't reduce, so the 5 moves to the front, and we get 5y plus 3. This one side reduces to a 2, so that becomes y plus 2. Final answers. Always look for those GCFs first. Okay, last but not least, 3 times 1 is 3. B term down at the bottom, divide by 3. So factors of 3 that might add up to be a negative 5. Well, we only have 3 and 1 that are factors of 3. And there's no way that's going to be negative 5. So what would the answer be here if this cannot be factored? Prime. Okay, it is not that there's no solution. It's just that it cannot be factored this way. We can still find a solution. It's just we'll learn how to do that later. All right, so good luck with that. I hope you like the VX method. It's my favorite. So, and it's pretty easy to learn, so good luck.